Hello students, I hope that you are good, well and fine. Today we will be continuing our discussion on NCERT miscellaneous exercise for chapter 1 Relations and Functions of class 12th. Okay, so let's move. We already discussed first and two questions. Now let's discuss the third question. As given a non-empty set X, consider Px, which is the set of all subset of X. This means power set of X. Okay, so what do we mean by power set? So for example, if A is my this set, then the power set of A is denoted by this, and this is set of all subsets of A. So as you can see that phi is a subset of A. This set is also subset of A. This set is also subset of A. And this set is also what? Subset of A. So the power set of A will be what? Set of all such subsets. So this, and this one. Okay, I hope that it is clear to you. And remember, the number of elements in power set will be 2 power elements in the set A. So this means elements in set A. Okay. I hope that it is clear from this. What you can say the number of elements in power set? 2, and elements in A is equals to 1 and 2. So this means 2. This means 2 power 2, which means 4. So as you can see over here, 1, 2, 3, 4. We got 4 elements. Okay. I hope that now it is clear that what do we mean by power set. So power set, which is the set of all subsets of X. Okay. Now we are going to define a relation R relation from Px, the power set, to power set as follows. Okay. So my R will be what? For subsets AB, okay, this pair AB, such that A related to B, or we only write two subsets of X in a pair when A is related to B, if A is subset of B. A is what? The subset of B, not equal to B, just a strict subset of it. Okay. Is R an equivalence relation on Px? So in order to be an equivalence relation, what do we need? We need, for equivalence relation, we need what? We need first that my relation is reflexive. Second, it is symmetric. And the last one, it is transitive. So let's check one by one that does it follows all of these things. For reflexive relation, what you can see is, we know for reflexive relation A comma A must belongs to the relation R for every A belongs to where? This set, which is power set of X. Okay. Can this happen? Can A be a subset? A be a subset of A? Yes. Can this happen? Can this happen? Okay. So we know A is equals to A and every set is a subset of itself. Okay. So it does can be true. Okay. But if you try to see in symmetric relation, but in symmetric relation, what we need relation whenever A B belongs to R, we need to show that B comma A also belongs to the relation R. Okay. If this happens, what this means is A is a subset of B. Okay. Okay. Now what? Now A is a subset of B. This means what this means? This doesn't imply that B is also going to be a subset of A. For example, let's say if X is my, let's say if X is my what set, say 1, 2, and as we know the Px is what? Phi 1, the set 2, and the set 1 comma 2. Okay. If you take this, it is indeed a subset of this set. Yes. So A is a subset of B, but if you try to see that B, does B a subset of A? No. As you can see that B is this bigger set and it is indeed not the subset for this small set over here. Okay. I hope that it is clear to you now. As also this symbol shows what it shows, that the equality, this shows that every element in here, this says every element in A must be in B. That's it. Every element in A must be in B. Okay. Okay. This shows this thing. Okay. Also, okay. So from this, we can say that what we can say from this example, as you saw that we have given an example which disprove this. So this means that it doesn't follows symmetric relation. So this means that we can say this is not an equivalence relation. Okay. I hope that you are getting the idea. So no, the given relation was not an equivalence relation. Okay, let's move next. Now question 4. Question 4, what it says, find the number of all onto functions from the set to itself. Okay, this is the set A. This is the domain set and this is the codomain set. Codomain set. The elements are 1, 2, 3, n, 1, 2, n. Okay. Now what? Now the what we are asked is that we have to find the all the onto functions. So let's see, what if we are talking about if A is just 1 and 2 elements. Okay, so let's see, the domain will be this, codomain will be this. So can you think how many onto function can you make? So for onto functions, every element in the codomain set must have a pre-image. What this means? This means that this is my codomain set, you all know that, and this is my what? Domain set. Okay, you all know that every element in the codomain set must be associated to some element from the domain set. This means one is, if suppose one is associated with one, and can 2 be associated with 1? No. If this happens, then if this happens, then it would not be a function at first place. Okay, why it would not be a function? Because it does not satisfy the function condition. In function, let me give you reason behind it. Because in functions no elements in domain set has two images, but here you can see that one has two images. One is associated with 1 and one is also associated with 2. So this cannot be happening. So this means we cannot do like this. Okay, now what? Now, okay, but so this means, what this means, codomain and domain. Okay, so this means if 1 is associated to 1, then 2 is going to associated with 2. Okay, is this onto? Yes. So one function we come up with is this one. This can also happen that 2 is going to associated with 1 and 1 is going to associated with 2. Can you think any other way? Yes, you can think, but say that this is associated with 1 and this is going to associated with 1. Indeed, this is a function. But what? It is not onto. But we need onto functions. Yes, we need such type of functions. What type of function? Onto functions. Why it is not onto? Because in onto function, no elements in the codomain set just living alone. As you can see here, 2 is not associated to any element. Okay, so because 2 has no pre-image. In onto, every element in the codomain set must have pre-image. Okay. I hope that it is clear. So that we cannot calculate this function also. Okay. So this means what? This means that in total we have arrived to only two functions. One is this and second one is this function. Okay. So if my set is of two elements, then the number of onto functions are going to be 2. Okay. If the number of elements in the set A is equals to 2, then the onto functions from A to A will be equals to what? 2. Okay. What about if we say that A is A, B, C? This means the number of elements in A is what? 3. As you can see, 1, 2, 3. So let's see over here. So the domain and the codomain is the same. Codomain and domain. Okay. Elements are A, B, C, A, B, C. So let's do one by one. If you associate A to A, B to B, C to C, it is onto. Yes. Okay. Now A, B, C, A, B, C. What about this? If you associate A to this B and B to A, B to C, okay, this is onto. Yes. Okay, this is what? Onto. Okay, now what? Now A, B, C, A, B, C. If you associated A to B, B to C, C to A, this is also onto, as you can see. Okay. Now A, B, C, 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 and A, B, C. Okay. Now what? A is associated to B. Okay. Then B here associated to C and C associated to A. Okay. Now what? Now my B is going to be associated with what? C. Sorry, A. Okay. Then A is going to be associated with C and C is going to be associated with A. Okay. Now C is associated to A. Okay. C is associated to A. A is associated to C and B is associated to B. Okay. As you can see, we are not repeating any function. Okay. So keep that thing in mind. Okay. As you can see, we are not repeating any function. Okay. Now what? As C associated to A. Okay. And okay. C associated to B. C. Now C associated to B. A associated to A and B associated to C. As you can see, none of my function is repeating. Can you find other than these 6 onto functions? Can you find other or the 7th? No, you cannot. Why? Because if you try to see, what we are doing is this, that the elements in here and in here are same. Okay. We are doing what? We are doing, as you can see, first A is related to A, then B is related to B and C is related to C. Okay. Then if you see over here, A is related to A, then I exchange the position. As you can see over here, in here, B is related to B, C is related to C. What I can do, I remain this association same, but exchange this as like this, as B going to C and C going to B. Okay. Now what? Now can you do other than this? Okay. So if A is associated to A, then I have only two such things. Okay. Now what? If A is associated to B, now I am fixing this association I am fixing. So I am fixing this association A to B, like this, A to B. I am fixing this and changing all other. So B is now related to A, C is related to C. Okay. Now I exchange these. C is now related to A and B now related to C. Okay. Now A is related to A, I have done. A is related to B, I have done. Now it's time for A is going to be related to C. As you can see, A is now related to C over here, A is now related to C over here. And now B is related to A and C is related to A. Now in here I exchanged B is related to B and C is related to C. Apart from these possibility, you cannot find any different possibilities. Okay, because every possibility is now exhausted. As you can see that A is related to every element in some way out of these 6 functions written over here. Okay, so if you try to see from this, that if I have what, say this is my first box, this is my second box, this is my third box, say 1 2 3. Okay, and I am going to fill what element in the first box. As you can see, what element I can fill in the first box, you can see I can either fix A, B or C. Yes, as you saw, I can either relate A with A or with B or with C. As you can see, these are the only possible things I can make. So 3 possibilities are there for first box. For second box, as you know, if one is related to this one, so I cannot use that element, so one is now used. So this means for the second box, how many elements I can use? Only 3. So 3 minus 1, which will be 2. And for the last box, what how many elements I can relate with? Only one element. Yes, because I have used one over here, one over here. In total I have 3 elements. So the only remaining element over here. So this means now just multiply them. What you will get? 3 times 2 times 1. The answer will be 6. Okay. So for this, whenever you have 3 elements or 3 element set, the number of onto functions will equals to be 6. Okay, now can you make some assertions? How? So if your set A have 2 elements, then the number of onto functions are equals to 2. This means 2 times 1. Okay. If A has 3 elements, then the answer is 6. This means 3 times 2 times 1. Can you think that what will be the answer if the elements in A are 4? So 1 2 3 4, or you can say just A B C D, whatever you can name it, A B C D, or P Q R S, whatever you want. Okay, how many you will get? From the previous ones, what you can say is 4 3 2 1. The number of onto function will be these. This means 12 24. So the 24 onto function you will be getting from A to A. And what A I am talking about? I am talking about this one, and this one. That's it. Okay. I hope that you are getting. So that's why if you have n boxes, then how you are going to arrange them. Okay, so in first box, how many elements can you fill or associate with n? In second, n minus 1, n minus 2 till 1. So this is nothing but, if you recall, this is nothing but the definition for the factorial. This means n factorial. So the actual answer or the correct answer for this will be what? If the set is my from A to A, and the cardinality of A or the number of elements in the set A is n, as you can see over here. So my onto function from A to A will be onto functions from A to A will be what? N factorial. Okay, I hope that it is quite clear to you. Okay, so that's it from my side today. We will be meeting in the next lecture. So thank you.